This formula is going to look familiar, and it's going to look familiar because it's going to look a lot like this. This is the length of an arc, we'll call it S, and it is on an interval from A to B, 1 plus the derivative squared, and then dx. That is arc length if we're just dealing with a regular function, f of x equals da 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 da. Well, now we're dealing with parametric equations, and so we are going to have a couple different issues with this. First of all, we're going to have to take the derivative of x and the derivative of y, and we're also going to have to, well, put them both in there. And then there's another little issue that we can't have the curve intersect itself except maybe at the endpoints. So if our interval for t, now, not x, but our t interval from A to B does like this, we're fine. But if our interval started here, went around and ended here, we'd have a problem because it couldn't intersect itself. That would complicate things. So we want to know the length of a curve given parametric equations, and this is the equation for that. And again, it looks super familiar, looks a lot like what you just saw about 25 or so seconds ago. And instead of f prime x, that would be like the derivative of y. In a sense, we're going to have the derivative of y and the derivative of x. It's the same kind of issue. So let's just jump right in. We're going to evaluate the length of the parametric curve given by this. And when we do that, we're going to need to take, well, the derivative of x and the derivative of y. So let's do it. dx dt is going to be, well, 0 plus 2t. And dy dt, I'm taking up lots of space here, is the complicated one. This is going to involve product and chain, and I think we got this. So f prime g plus f, and then the derivative of sine of 2t would be cosine of 2t times 2. We'll put the 2 in the front. And we're going to put all of this into that right there. And we're going to go on the interval from 0 to 3. And so we have this, you got this. Setup is pretty straightforward. So 2t, it is squared. Call that 4t squared if you like. Just be careful. Be careful with what you simplify and how you simplify it. E to the t sine of 2t plus 2e to the t cosine of 2t. And we're going to do this one without a calculator. I'm really kidding. We are going to use a calculator. And I am going to grab my calculator super fast. That was not fast enough, was it? You can type this in as if you're in function mode and treat them like x's. You can totally do that. And I'm going to do that, but I also want to show you a different way of going about this. And just because I noticed it, and it is probably not an issue for you, but it's just a good habit, so I'll say it now. I'm in degrees. I'm in degrees. Why was I in degrees when I'm a calculus teacher? Funny you should ask. Remind me, I'll tell you later. I need to be in radians. And I am in function mode. So again, parametric if you like, I will in a minute. I'm going to show you more than one way of going about this. So just a regular way, you've seen this before, 0 to 3 square root of 2x squared, and then plus. And everything you're seeing here is everything that you probably would have done anyway. So no surprises. 2e to the t. So what I was doing, I'm trying to talk and type at the same time. I was trying to figure out the angle of something that I'm building, and I needed to use degrees instead of radians. I sure hope this is 25.537. I sure hope it shows up in the next 4 hours. Oh, it is. 25.537. Yes. Okay. Let me show you something else that you could do with this, and it's really neat. I'm going to go to parametric mode. So parametric mode, we're going to press y equals, and we're going to type, well, let's clear out what we have. We're going to type the original, which would be 2 plus t squared. Whoops, 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 whoops. 2 plus t squared. And then the y is e to the t sine of 2t, okay? And I could find the derivatives and put them here. I'm actually not. I'm going to jump straight to the big idea. Well, let's do it here. Let's do it from there. So math 9. By the way, I quit right there, just in case I'm pressing a bunch of buttons and you're like, what happened? I pressed second and quit. You probably know that, but press buttons and don't even tell people what I'm pressing. So we're going to go from 0 to 3 of the square root of, all right, about to get crazy, parenthesis because we need it, math 8, that is the derivative with respect to t of the x function. We're going to press alpha and trace and pull up the x1 function at any given t value. At what t value? Just any t value. And then we will parenthesize that, and we're going to square it. And we have just taken care of this part. Now we're going to move on to this part. So plus, parenthesis, math 8 dt of the y portion. At any given t value, we will parenthesize and close that out, and then dt. Now, I have encountered it before where it's just way too much for it to compute and it won't do it. So we might have to sit here for a minute. And while it's sitting, I'll just make idle chit-chat, or I'll go on to the next problem. So I do recommend you do that. Make the best use of your time. If you're in a timed situation, like on the AP exam, and you did something like this, and you're just twiddling your thumbs. No, move on. And there it goes, 25.537. Come back to it. Just don't get misaligned with the what, with the way you're bubbling your answers. You know what I'm trying to say. All right. The path of a runner is modeled by this parametric equation, these parametric equations here, where x and y are measured in meters and t is measured in seconds. How far did the runner travel on the interval from 0 to 2 pi? By the way, if you were to graph this, you would see that it is an ellipse, and he runs a lap or two. Let's graph that just for the sake of seeing it, because we have the time. We are not in the timed test at the moment. 10 cosine of t and 20 cosine of t. Whoops, 20 sine of t. My fault. 20 sine of t. And we're going to graph this from 0 to 2 pi. That is 2 pi. So let's go to a standard window. Zoom standard. Oh, we don't see it, but it went around like that, and that does, when I pressed zoom standard in my heart, I was thinking, my mathematical heart, I was thinking maybe it's going to adjust the t values. It didn't. On a calculator, the default t values are 0 to 2 pi, so convenient for this problem. Anyway, from 0 to 2 pi, let's adjust the x's and the y's. Negative 10 to 10 for x was fine. We can see that. The y values, I think you have a good guess. We should go from negative 20 to 20, and we'll graph that. There it is. It is an oval ellipse that is taller than it is wide. I know this looks wider than it is tall, but notice that this goes from negative 20 to 20, and that goes from negative 10 to 10. So it's actually taller than it is wide. It's just scaled in such a way that you can't see it. Just because I want to, I'm going to change this to pi, and that would only be halfway around the track. Okay, so I just want to know how long it is around this elliptical track. So let's do it. We are going to, sorry, my chair just popped. We are going to go from 0 to 2 pi. You can see where this is going. Some squared stuff here and some squared stuff here, and then dt here. And the derivative of 10 cosine would be negative 10 sine t. For our purposes, the fact that it's negative is irrelevant because it's about to get squared anyway, but for consistency, we'll keep it. So 20 cosine of t. And we'll type that in, and we'll just type it in exactly the way it looks. Math 9, 0 to 2 pi, and square root of negative, because we should, just, good habit. Don't throw away those things. Squared plus 20 cosine of t, and it is squared, and there we go. I predict 96.884, just off the top of my head. Oh, yeah, okay. Sorry, I couldn't give you more decimals than that. That's all I could do in my head. 96.884.